Hello everyone. So as I said before, in this video I wanted to talk about the delegation cycle and the rewards calculation and distribution. And now it's a lot of people I think just take it for granted, but it's actually a very complex process. So I wanted to make a video where I go from beginning to end. And cover every part of the delegation cycle and the rewards calculation, and give you some tools at the end that you can use yourself for the calculations of rewards and block assignments, well, the probabilities of block assignments. So let's get started and see what we'll cover in this presentation, and then after the presentation we'll go into the practical side of actual calculations. So what I want to cover is the delegation cycle. Well, this should really be somewhere over here, because it includes everything that's listed below it. So okay, first I want to talk about the stake snapshots. So basically the difference between active and live stake, and how they are related, and how what each one means. Then the rewards calculation. So that's going to be the complex part of the system, and in there we're going to talk about apparent pool performance, as well as the two scenarios where the centralization factor is higher or equal than 0.8, and when it is lower than 0.8, as that has a significant impact on the protocol, as because of the way it's set up. And then the distribution, I just want to cover when actually the rewards are distributed, as well as how the pool costs and fees are taken out of there, and how the rest is distributed among delegators. So I'm going to be using this delegation cycle graphic from Cardano to illustrate how things are happening, as it nicely lets us know what's going on from epoch to epoch. Just so you know, I'm going to be going back and forth between this graphic and the other content of the presentation. So the first piece of the puzzle are the stake snapshots. Now, why are they important? They essentially capture the state of stake distribution among pools, as well as the total amount of ADA staked at the. You can either think of it as at the end of an epoch or at the beginning of the next epoch. Whichever you do, it's fine, because it happens at the boundary. I'm going to be using the beginning of the next epoch as the time where the snapshot is taken. So for consistency, that's how I'll be referring to it. Now, why are these two important? Because the protocol uses those two to create the slot leader schedule. So basically, based on the distribution among pools, it assigns slots to different pools. So pools with more stake will have more chance of getting more slots. So that's why the snapshots happen. And now if we go back to the graphic, we see that if a snapshot is taken, so as I said, I'm going to term this the in this example beginning of epoch 210. Then this epoch 210 will it will go through the epoch, and only at the next epoch, after the next snapshot is taken, will this one become active. So the stake from this snapshot will be the active stake in the epoch n+1, if you consider that the stake snapshot was taken at the beginning of epoch 210. If you consider the snapshot is taken at the end of epoch 209, which is not really incorrect, then it would be n+2. But I want to reduce the numbers of n plus xy, so I will be referring to as the beginning of epoch 210. Now that brings us to the difference between active stake and live stake. So the active stake is the stake that has been captured by this snapshot taken at the start of the previous epoch. So it is a static value. Once the snapshot is taken and once that snapshot becomes active, that's the active stake, and it doesn't change throughout the epoch. Okay, this is the stake that is used for creating the leader schedule and for calculating rewards in the next epoch. And when I say in the next epoch, I mean the epoch that the blocks are produced by stake pools. You don't get rewards at the end of that epoch, but the rewards are calculated in the next epoch, and then you get them at the beginning of the one after that. The live stake is, on the other hand, a dynamic value, because you can think of it as the absolute current stake of a stake pool. So it is the stake that will be captured in the next snapshot. That means that if you get a new delegation right now, it will change your live stake. It won't affect your active stake, but if that delegation stays there until the end of the epoch, then it will become active stake in the epoch after the next one, as we talked about a little earlier. And yeah, that's what I said. So it will become the active stake at the beginning of the epoch after the next one. So let's just get back to our graphic. So the last time we stopped here when delegation was active, and we know now that the active stake is what controls how blocks are assigned. And then after that epoch ends and we go into the next one, we get to the rewards calculations. So let's get into that. So to do rewards calculations, we need a lot of variables, and this is where things get a little bit complicated. So I tried to divide them into three categories. So let's start with the blockchain parameters first. These are variables that are set in the protocol. They can change. Some of them, will probably remain the same for quite a bit of time. Others change from epoch to epoch. So let's start with D. Now, I heard people refer to this as decentralization factor, but I think centralization factor is actually a more suiting name because it's the ratio of blocks created by IOG to blocks created by stake pools. So the higher it is, the more centralized Cardano is. So when D is 0, then we have a completely decentralized system where all the blocks are produced by stake pools. K is the optimal number of pools. So currently it is set to 150, and this is what controls the saturation point of any stake pool. So with 150, it is currently at around 210 million. Tau is the treasury tax, which it's a tax that is taken from the total rewards available for an epoch and is sent to the treasury, which is it's not the Cardano reserves, but it's like a separate container. So it's just sent to the treasury for use of for later use. For what exactly, that's sort of the thing that we as a community will be able to vote on and decide how it's used. The raw parameter is the monetary expansion factor. It's currently set to 0.3%, and this is basically the factor that controls how much of the Cardano reserves are going to be transferred into Cardano rewards every epoch. So we'll get to that later. If it's a bit foggy now, don't worry. Just know that it controls the amount of rewards, basically. Then we have TM. I labeled it as TM, and that is the the maximum supply of ADA, which is set to 45 billion. That will never change, so there will never be more than 45 billion of ADA coins in circulation. Now we can get to the apparent pool performance. There are only two parameters that control that, and that are the beta, which is the ratio of blocks created by a stake pool relative to the number of blocks created by all stake pools. Well, it's pretty self-explanatory. It's just if you consider, yourself a stake pool, then it's the number of block I produced and the ratio of all blocks produced by stake pools, which is controlled by the D parameter. The sigma A is the relative stake of the pool. So this controls our chance of getting a block assigned to us, and it is the relative stake of the pool. So the ratio of our active stake to the total active stake. So when I say total active stake, I mean the amount of ADA that is staked. If you remember from the snapshot, it captures the distribution of stake among pools, and it captures the total amount of ADA that has been delegated. So that total amount of ADA is the active stake, not to be confused with the total supply of ADA in circulation, which we'll get to soon. In the rewards category, I put RT, that will be the total rewards for the epoch, and the formula will actually be on the next slide, but we can just go through it now. It will be TM, which is the maximum supply of ADA, minus T, which is the total supply of ADA I meant to put in circulation here, so the coins that are distributed at the moment, times rho, the expansion factor, which I mentioned. So this is what controls how much of the reserves gets transferred into rewards, and plus transaction fees. Now, so all of the transaction fees from an epoch, cumulatively, at the end, they're joined together and they get transferred into the rewards pot. So I put a star here because I'm not really sure what number this is. I know in the IOHK papers they used an example of 2000 ADA. So yeah, it does get added to the rewards pot, but it might be a very small number. Of course, with Cardano adoption, there will be more and more transactions, and with that, more and more transaction fees, so it might become a significant number that then also gives us more rewards. So the more people use Cardano, the more ADA goes into rewards from transaction fees. Then RE is the expected rewards per epoch. Now I put expected here because it assumes that all the blocks are produced, which is not always the case. We don't have a 100% performance, so it's actually a little bit less than this, but I should have really put, instead of expected, like optimal. But this will be our rewards per epoch. Then T we already covered. R is the expected ratio of rewards per year staked. So it's like ROS, but we're actually not going to use that number in my calculations. I forgot to take it off, so don't worry about that. A0 is the pledge factor, which specifies how much influence a pool's pledge has on the rewards. So right now it's set to 0.3, which a lot of people say it's not very significant. So a pool with a small pledge and a large pledge will get very similar rewards, but nevertheless that is what it is. Then sigma prime is the pool stake relative to the total supply of ADA. Now this is important to distinguish the sigma prime and the sigma A. So sigma A, as we covered, is the relative stake of the pool relative to the total active stake, and the sigma prime is the pool stake relative to the total supply of ADA. So not active state, but total supply, which is T. The next thing is Z0, which is the saturation point, as we mentioned, controlled by the K parameter. And this is the formula that you can use to get the saturation amount of ADA, which will be around 213, I think, million of ADA. S prime is the pool owner's relative stake, so it's basically the amount of pool pledge, and it's relative to the total supply again. So you might notice that rewards are actually calculated based on the total supply of ADA and not the active stake, which is an important thing to distinguish. And then we have the P, which is going to be the apparent pool performance, a very important factor, which we're going to get to soon. Now that we know all the variables, we can start talking about the formulas. So the way we're going to calculate rewards is first we're going to calculate all of the rewards for an epoch, and we will calculate that in a way that RE is going to be the absolute total rewards, which is, as we mentioned, controlled by the amount of ADA in circulation and the monetary expansion factor. So TM is the maximum supply, so 45 billion, that never changes, but the amount of ADA in circulation does change. So now it's around 31.7 billion. The important thing to understand here is that with every epoch, this T number will increase. Why? Because some of ADA from reserves are going to get transferred into rewards. Those rewards are going to go into users' wallets, and by doing that, we are putting them into circulation. So this number T increases over time, which means this number RE decreases over time. So as we move from epoch to epoch, rewards get smaller and smaller. And then R is the actual, I mean, when I say actual, I mean the amount of rewards that is available for stake pools once the treasury tax is taken out of the total amount. So now we can use this R to calculate the optimal pool rewards. And when I say optimal and put a star there, I mean that it assumes 100% pool performance. Well, 100% apparent pool performance. Let's actually just talk a little bit about that apparent pool performance. Why do we call it apparent? Because the protocol is set up in a way that nobody knows the schedule of blocks. So only you know how many blocks you were assigned and how many you created. I mean, okay, everyone knows how many you created, but only you know how many you were assigned. So that's why only you can know your real performance. For everything else, we have to calculate the apparent performance, which will basically be calculated as how many blocks you produced against how many blocks you were expected to produce based on your active stake that you control. Now, with that out of the way, we will, so the optimal pool rewards are a function of S, which is the owner's stake, like the pledge, and sigma, the total stake, total active stake controlled by the pool. So the formula takes the total reserves and then takes into account the pledge factor, the as we said, sigma prime, the ratio of the stake pool's active stake to total supply of ADA, and then again for the pledge, it takes the owner's pledge and the pledge factor, and again takes these numbers to calculate the rewards. So those are the optimal pool rewards, as we said, but they assume the performance of pools set to 1. The real apparent performance is calculated as beta, as we said. The number of blocks your pool produced divided by the number of all blocks produced by stake pools, and over your relative stake that you control. So you can actually translate this into like how many blocks you created over how many blocks you were expected to create. That is the apparent performance I mentioned before. And then the final rewards formula is then a function of both the owner stake, the total pool stake, and the apparent performance, and it's just this optimal pools formula multiplied by the apparent performance. Now I want to talk about the two different scenarios which are controlled by the D parameter and in turn control how apparent performance is calculated or not calculated. So in the first scenario, the so-called transition phase, where the D parameter is set to be greater or equal to 0.8, the apparent performance of any pool is set to 1. Now, this is actually very favorable for large pools because if you imagine a large pool that gets, for example, 100 blocks assigned to it, and it creates only one block out of those 100, it will get rewarded as if it created all 100 blocks, because its performance will be set to 1 by default. On the other hand, if you consider a very small pool that gets that shouldn't even get a block but gets lucky and gets a block and it creates it, it will be rewarded only. It will be rewarded as if it created less than a block. It will only be rewarded for the amount of stake it controls, because its apparent performance cannot go above 1. But if you think about it, that pool created 1 block, and it's expected to create, let's say, less than 1, let's say 0.5 blocks. Then if you divide that, you get apparent performance of 2. So that would double its rewards. But because of this scenario where D is set to 0 above 0.8, its performance cannot go above 1. So small pools that get lucky might be expecting high returns on rewards, but that's not going to be the case until the D parameter is set to below 0.8, because at this point then apparent performance is really calculated, and then in that case with the small pool it would get in the example I mentioned, if it created 1 block when it should create only 0.5 blocks, it will be rewarded properly for that. And the large pools will be properly, how should I say, disrewarded, if they miss any of their block assignments. So while this seems, very favorable for large pools and unfair to small pools, and I will show you this concept in the next section of the video, where we'll do calculations. It seems unfair, but it's also a necessary measure in the transition phase, because if you think about it, most of the small pools are not going to get a block, right? When we talk about probability, some of them will get lucky and get it, but most of them won't. If we didn't have this apparent performance set to 1, then once the rankings are up in Daedalus, those small pools that didn't create a block, would have their performance as 0, and meaning that they would rank very, very low. But when in fact, they might be perfectly fine stake pools that have the ability to produce blocks, but they just didn't get it. So this condition counters that by setting it to 1 by default, so that once the initial rankings are out, basically all the stake pools are considered equal. However, that comes with a cost of favoring large pools in this transition phase with regards to rewards. So once again, back to our delegation cycle board. We covered all of this so far, and now we were in this epoch where we calculated the rewards. And now another important thing to note is, as I mentioned before, actually, that the rewards are calculated in this epoch, and then they're delivered in the epoch in the next epoch. So it's important for delegators to know that it does take some time from delegation to actual rewards to happen. So if we consider this snapshot taken at the beginning of epoch 2010, they would receive the rewards at in epoch 213, so n plus 3. Again, if we consider this snapshot taken at the end of epoch 209, then we can consider it n+4 to epoch 213. But in any case, let's just go through the rewards distribution after they are calculated. So the rewards are calculated according to the formulas I showed you. Then from those rewards for a stake pool, the pool's fixed fee is taken out first. From the remaining reward amount, the pool margin fee is taken out, and the rest is distributed to the delegators in a way that the more stake you had with the pool, the more rewards you get. So if you delegated 1 million to a pool that has 2 million stake in total, you will get 50% of the rewards that are here to be distributed among delegators. So I think that's it for this presentation, and now I'm going to show you some real calculations. So this was mostly theory, and now let's do some practical calculations as well. So here's a spreadsheet I created for rewards calculation and some more stuff. Let's start with this. So I took my own pool as the example, and here I pretty much just listed all the variables we talked about. So blocks will be the number of blocks produced by stake pools. Rho will be the monetary expansion factor, tau the treasury tax, K the optimal number of stake pools, D is the centralization factor, so we are considering epoch 211 in which it's set to 0.9 and controls the number of blocks produced by stake pools. So if we change that, that will change as well. So that's 0.9. The maximum ADA supply, 45 billion. The total ADA supply currently in circulation. Now this number, I'm fairly confident that it's correct. I took it off of PoolTool. There is a way to make a query yourself with the database sync. I don't know how to call it, feature of Cardano node. But I'm fairly confident that that's exactly what's listed on PoolTool. So it's 31.7 billion. Now it's probably not a perfectly rounded number like this, but it's very close to this. So for calculations, it's fine. TS is the total active stake. So that's the stake that was captured in the snapshot that's currently active in this epoch 211. PS is pool active stake. So Eden's active stake at the moment. OS is the owner stake, so this is my pledge amount, and then we can go into blocks. So the expected blocks is just the number of total blocks that are produced by stake pools times my relative active stake share. So Eden was expected to produce 0.96 blocks this epoch, but it produced 2, and we'll get onto that later. But as I mentioned in the presentation, the apparent performance set to 1 means that I'm not going to get any extra reward for this second block. I will be rewarded as if I created 0.96 blocks. Beta is the relative blocks produced. So this is I put 2 here, but this is actually, I can make it dynamic. So it's the number of my own blocks produced by Eden divided by the total number of blocks produced by stake pools. the relative active stake of the stake pool, as we mentioned, apparent pool performance. Now I put a if statement here, so if the parameter is less than 0.8, then we will calculate this using these two numbers, and if it's not, then it's set to 1 automatically. R is the expected loss. We're not going to use that, forget about that. RE, the total rewards per epoch, although I calculated here as well, it's, as we mentioned, the total maximum ADA supply minus the total ADA supply times the monetary expansion factor rho. So I actually hard-coded that in, but it should be rho. There we go. And I just divided to get this number in millions. A0, the pledge influence. So sigma prime, as we talked about, this is used in the rewards formula to calculate rewards. It's the pool's active stake relative to the total supply. The saturation point of any pool, 211 million. And S prime is the owner stake, owner active stake over total supply. So first we can calculate the total amount of reserves. We do that just by subtracting the total supply of ADA in circulation over the total, the maximum supply of ADA, and we get 13.3 billion. Now, before we move on, let me just show you this thing. Here I calculated the total reserves and how they will decrease. I don't want to do this. How they will decrease over epoch after epoch. So why is that? As I said, these rewards that get transferred in epoch 211, we will get 39.9 million of ADA in rewards. So it will go from reserves into circulation. So that's the so this number will be the total reserves we had at the start minus the reserves we put into the circulation. So this will get lower and lower with time, and that's illustrated in this graph. And on this side, we have the rewards. So because the reserves decrease, the rewards also decrease. And the blue is just before taxes, and the orange is after taxes, but they decrease in the same manner as it's just 20% tax. Just wanted to illustrate that and make it maybe a little bit more visual and understandable. Anyway, as I said, the rewards for this epoch are going to be 39.9 million. And after, so those are the total rewards. These are the rewards that actually, okay, they will be a little bit higher. If you remember, I mentioned the transaction fees. So I didn't add the transaction fees here because, it's hard to know what the cumulative amount of transaction fees is going to be at the end of an epoch. But it's a small amount, so it wouldn't, change the numbers very much. So these are the total rewards available, and this is the number from which the treasury tax is taken out. So after that tax, we have 31.92 million of rewards to be distributed among all stake pools. Now that we have that number, that R, we can calculate the optimal rewards for a stake pool using this formula. Here I just entered this formula into this field, and I got, for example, for my pool, 3.408. And to be perfectly clear, this should be wrapped in an if statement, so that if the number of blocks produced is 0, so if this is let's say if it's more than 0, then it will get this value that I entered. Otherwise, it will be 0. So now this didn't change anything here, but if I put 0 blocks produced here, I will not get any rewards. We'll get more into like how rewards are affected by this stuff later on, but let's just go through the whole calculation first. So optimal rewards are calculated from this formula, and as we know, optimal rewards assume the apparent performance of a pool to be 1. As we also know, the D parameter is above 0.8, so apparent performance is always set to 1 anyway. That's why optimal rewards and real rewards for Eden are the same. That's so that's just apparent performance multiplied by this number, and that's it. We calculated the rewards for our pool, and now we can get on to rewards distribution. So from this number, the first thing that's going to happen is we're going to take out the fixed cost. So this will only be taken out if we have, rewards, but we take out 340 ADA, the minimum pool cost, and then from this number we take out the 2% margin. So as you can see, the margin is actually only 62 ADA, and the rest is distributed among delegators. So for example, I had 4.4 million total stake, so if someone delegated 2.2 million to my pool, they would get 50% of the rewards, which would mean they get exactly 1,500 ADA in rewards. Yeah, that's it. Now, what I want to illustrate to you is what I've been talking about before with the apparent performance. Why does it favor large pools so much? Well, let's first imagine that I only got 1 block instead of 2 blocks. What do you think the rewards should change with that? Well, they don't. Why? Because no matter how many blocks I'm expected to create and how many blocks I create, as long as I create 1 block, I will get my optimal pool rewards. Which means that if a pool, and let's set this to 0 now, let's imagine a very large pool. Let's imagine 200 million. This is 20 million, 200 million. That pool would be expected to create 43 blocks. Imagine that it only creates 1 block out of those. How much rewards do you think it will get? 154,000 ADA. What if it created 100 blocks? 154,000 ADA still. It doesn't matter. As long as you create 1 block, your performance is going to be set to 1, and you're going to get the rewards that are only relative to your active stake. So you can see that how large pools can benefit from that. They don't have to perform very well, but they will get all their rewards. Now let's consider small pools. The situation for small pools is actually not very good. Let's imagine a very small pool that has less than 500,000 of ADA stake. So let's say it has 400,000. that pool is expected to create 0.087 blocks. If it creates one block, that is, it's a very lucky pool. But again, because the apparent performance is going to be set to 1, it will only receive a very small amount of rewards. In this case, not even enough to cover the fixed cost. So the delegators won't receive anything, and not even the fixed cost will be fulfilled. Now, this is because of the condition where the apparent performance is set to 1 when d is greater or equal than 0.8. If this pool was to create a block, get lucky with an assignment, when the d parameter is less than 0.8, 0.7, for example, what do you think is going to happen to the rewards? They're going to jump up high. Why? Because what do you think is going to happen to the apparent pool performance? Yes, it's going to be a lot higher, because the pool is expected to create only 0.26 blocks, and it creates 1, which is more than it's expected to do. So its apparent performance is higher. And even though its optimal pool rewards, which assume performance of 100%, are 309, it will get 3,500, because this optimal rewards will be the optimal reward number will be multiplied by its apparent performance. So you see, because of this condition with the d parameter, the small pools who get lucky with a block, normally would expect a high ROS, but it's not going to happen until the d parameter decreases below 0.8. That's it for the calculations. Now I have shown you the decrease of reserves, and one thing I want to show you is the block assignment probability. So here I consider epoch 212, where the d parameter will be set to 0.8. Why is this important in this particular calculation? Is because it controls the number of blocks. So instead of 2,160 blocks as we had in epoch 211, we're going to have double that in epoch 212. So again, I'm taking my pool as the as an example, and it's going to have 4.26 million active stake in epoch 212, so a little bit less than in epoch 211. And the total stake, you notice that it also is changed. So from epoch, the snapshot that is active in epoch 211, when the total active stake was 9.87, in epoch 212, the snapshot that is active has more ADA stake, so the total stake is higher. Now, what is this P? This is the probability of getting a slot assigned to you for each block that gets assigned. So we have 4,320 blocks that are going to be produced, that should be produced by stake pools. And for each one of those blocks, you have, I have 0.00035 chance of getting that blocks assigned to you. So for most of them, it's not going to be assigned to me. But because this number is sort of high, there actually is a good chance that I'll get at least one block. So the situation is that Eden has a 22.05% chance of not getting a block assigned to it in epoch 212, which we can from that calculate the chance of getting one or more blocks. So 78% for Eden to get a block in epoch 212. I mean, not bad, but not great either. And if you see this graph, you can see that it kind of forms a bell curve. So it's binomial distribution, the Gauss curve that we see in a lot of places in nature. And why it looks like, I guess it doesn't look like a curve now, but if you imagine this part of it, you can imagine that it looks like a curve. Why is this? Well, because there are basically not enough block assignments, so not enough instances of, if you consider every block assignment as an experiment, then there aren't enough experiments to create a complete normal distribution. But if we decrease the D parameter, which will increase the block numbers that are created by stake pools, then we will see a different picture. So as this number increases, this will be more and more, let's say, fair, actually. And you see that in that case, my chance of not getting a block is significantly lower because there are a lot more block assignments. So there's a lower probability that I won't get any of them since the number increased. Yeah, that's about it. But you have to consider that if D is 0, by that time the total active stake will also increase. So if we consider like 31.7 billion to be delegated, so like all of the ADA supply, then you can see that decreases my chance of getting at least one block assigned, or it increases my chance of getting 0 blocks assigned. So the total stake increasing in general decreases your chance to get a block assigned, but the D parameter it seems like it's more strong in increasing your chances. So I wouldn't worry too much, but just keep in mind that with the apparent pool performance parameter, you really only need to get one block assigned to you, and that's that. You can get one block, you can get 100 blocks. If you create just one, you will get the rewards you are supposed to get, and that's it. So luck, cuts out at that point. If you consider yourself lucky that you got 3 blocks, it doesn't matter. But that will change, as I described, when the D parameter is lowered. So I hope you find this video helpful. I wanted to make it both for delegators and for stake pool operators to understand what's going on and to understand the whole delegation cycle from start to finish. I hope I have succeeded in that. If anything is unclear, feel free to get in touch with me on Telegram or Twitter or wherever you want. If you think I made a mistake somewhere, please tell me. This is a very complex subject, actually, so I'm happy to discuss it with anyone. And that's it. No real stake pool operations for today, but I think this video on this stuff was due. As I said, both for delegators and stake pool operators. That's probably it for me this weekend. I will see you, next weekend when I'll decide what video to do. I might put up a poll on Twitter or Telegram. I don't know, because a lot of you have suggested a lot of stuff now, and I think it would be fair, much like Cardano, has its voting system, to let the community, to let you guys vote on what you would want me to cover next. And then I can tell you, no, I'm not going to do that. I'm going to do what I want. No, just kidding. If a lot of people want me to cover, a particular subject, I don't mind at all. So, I appreciate the suggestions, of course. Even without the voting stuff, it helps me plan on what to do. So thanks for watching. Yeah. Good luck. Small pools, stay strong. You need to tough it out until the D parameter is lowered, and then you can really start to hit it off. See you guys next time. One more thing. I have to make a tribute to one of the CN Tool developers, Paul Dorogi. His pool is ticker under. It will be in the description below. I have discussed with him about this stuff for the last few days. He has been extremely helpful and patient, and helped me understand all of this. So really, thank you very much, Paul. And he is extremely knowledgeable about the whole Cardano protocol. So I invite you guys to delegate to his pool, and if you find this helpful, you should be thankful to him as well for helping me get this done. See you.